Hi everybody, I'm making this video to help clarify some matters concerning how we interpret data and read the numbers and make sense of what we're looking at so that we can have meaningful conversations and speak accurately about the things we're seeing. So here we go. Why is this important? Because interpreting data accurately is really important when we draw conclusions about teaching and gauging the progress we've made in our classrooms with students. There are several common misconceptions or misunderstandings that can lead people to celebrate or panic when they shouldn't because they misinterpret the numbers. Conversely speaking, the language of data allows us to make sense of what we're seeing, and the numbers become a story that we can read and learn from. And this is really important. I think that the people that are making decisions about kids and their learning, or administrators looking at trends with teachers and things like that, if you react to things that aren't problems or you don't react to things that are problems, both present their own negative issues. So, you see our little boy up there wondering, he's having a thoughtful moment. Is that good? So one of the best reasons for understanding data is to determine if the results indicate a cause for celebration or concern. But how do we know what good is? What is the way we define progress? So take a scenario. Let's say a student reads 85 words per minute on the fall reading benchmark, and then 125 words per minute on the winter reading benchmark. He grew 40 words per minute. That's great, right? I mean, he grew. It depends on the performance of his peers. Think of it this way. If the average increase is 20 words per minute, then this student is doing really well. He did well better than the average increase. If the average increase is 60 words per minute, not so hot. We can't be happy with just any growth. We need to know the larger context. And this is where people will say to me, hey, well, she grew by X amount of progress, whatever rate, and I find that they've fallen backwards they've not kept up with their peer group in the percentiles, which we'll talk about next. So yes, growth is good. But I think if we're really going to be honest about things like TVOS and how growth is calculated, some growth is not the same as enough growth. And enough growth is determined by cohorts and the speed at which the whole group seems to move. And we'll talk about that next. So the idea of percentile. A percentile is the percentage of people in your group that you outperformed. And really, to be more clear, it's you outperformed or equaled their performance. So, for example, let's say somebody named Amanda, her math EasyCBM score placed her in the 89th percentile. This indicates that she performed as well as or better than 89% of her peers. Doesn't mean she got 89% right. It just means that she performed better than 89% of her peers. Percentiles, however, are not evenly spaced apart, which means that a person who moves from 10th to the 20th percentile is not the same as a person who's moved from the 20th to the 30th. Now you'll say to yourself, but it's still 10 points. That's true, but the way that the normal curve looks, and we'll talk about this next, makes a difference in terms of the significance of that movement. So this is a normal curve. We've seen this before, the distribution of scores that are common, statistical representation of how scores tend to cluster around the average. So we look here, this is the average, 50th percentile, right there in the middle. Ignore the other numbers for now, we'll talk about them next. The further away you get from the 50th percentile, the fewer the scores. If you think about it this way, the higher it is vertically, the more frequent those scores are. So a lot of people are scoring around the 50th percentile. If you look here at the 40th percentile, lots scoring up there. 60th, lots of frequency, lots of people are up here. The lower you get down in either direction, fewer people are scoring. Think about a rubber band that you take. It's not hard to stretch it here. Getting harder, getting harder, getting harder, getting harder. So the movement to get from the 80th to the 90th is more difficult than to get from the 50th to the 60th. Notice that this span is tinier, a little bigger, a little bigger, a little bigger. It's really hard to get from 9th to 95th, even harder from 95th to 99th. Same thing on the negative side. The further you get away, the scores become less frequent, the number of people getting those scores going down. Think about a rubber band. So So normal curve equivalent, what is that talking about? Normal curve equivalents help us to determine the significance of a percentile change. So because we know that moving from the 10th to 20th is a different degree of significance than the 20th to the 30th, this line up here, this red line, equally breaks it up so that you can make an apples to apples comparison of percentiles. So this is kind of going back to my rubber band point. The lower the score falls vertically on the curve, up vertically, down, the less movement is necessary to indicate significance. Meaning that if I'm down here, if I move around in here, that's much more, the amount I move is much more significant than if I move around in here. Because everybody's score is clustered up here, for the most part. Lots of people are in this range in here. Lots of people. I'll give you some more quantitative examples. So using the normal curve equivalent graphic, the following movements carry similar significance. So if I go from the 10th to the 21st percentile, here's my percentiles. If I go from the 10th to just above there, I'll put my fingers up here. The distance there is the same distance as if you went 50th to 69th, because the 50th to 70th are really clustered together, but the gap is the same. And the 90th to the 96th, you'll notice that 10th to 21st, that's 11 points. But still, it's the same significance as 50 to 69, which is 19 points, and 90 to 96 is only 6 points. And yet, if you put your finger up to it, that gap is the same gap, I'm trying not to move my fingers, I know it's hard to see, as 10th to 21st, or as 50th to 69th. This is why when schools say, well, we already perform really high, how can we get a good score in TVOS? That's because if you have a school that scores in the 80th percentile, for you to make a normal curve equivalent growth of 10, let's say you wanted to go from, let's say you were an 85, so you're at the 70th, and you want to grow 10, your goal to grow 10 would be to go from the 85th percentile to the 93rd maybe, whereas a guy down here to grow 10 would have to go from the 50th to about the 69th. So what's required of you is much less, even if you're high performing, than your lower performing peers or colleagues or schools or whatever else, because of the equality created by the normal curve equivalence. This is how TVOS is a fair thing, regardless of your performance category. So how can a teacher, coach, administrator use this information? If you understand how to interpret percentiles and normal curve equivalence, you'll soon find that data is your friend. Practical application. Let's pretend a teacher wants to flag any student that has increased their percentile score by at least 10 normal curve equivalents. So going back here for a second. I lied, I'm not going back there. In this scenario, a student that increases from the 50th to the 65th percentile has not made noteworthy growth, because that would not be a large enough span. I'll go back to that, 50th to 65th. So from here, and the good news here is this 50 lines up with that 50. Here to there, that 65 is short of 60, so I could have not made a growth of 10. It did not happen. However, a student that increases from the 70th to the 85th has made noteworthy growth. Even though both students increased by 15 percentile points, the second student has accomplished something more difficult. So remember that number, 70 to 85. If I go from 70, which is about 61, to 85, that's going to be at least 71 or past. I've made my requisite 10 I was looking for. Same thing if you want to say, am I concerned about a drop? You can use this normal curve equivalent right above the percentile equivalence to determine if the movement is in your category you've created of significance. So data isn't scary. It's a language. It's one that you can speak. And I think it's something that if we are informed about and we use accurately, we'll be able to make smarter decisions, talk intelligently, and not find problems where they don't exist, and identify the problems where they do. Hope this makes sense, and that you've enjoyed this video.